Okay, so thanks. My name's Jamie Kennea. I'm from Penn State, and I'm here to talk about ACROSS, which is a NASA initiative. The Astro-Decadal Survey 2020 basically told NASA to support TDAM. And the ways that it told NASA to support TDAM included spending large amounts of money on missions, which unfortunately NASA doesn't have the money to do. So we decided to they were going to form a TDAM initiative, which has become ACROSS. And the idea here was to support TDAM workshops. So there have been 2 TDAM workshops, and now there's going to be a 3rd one in LSU next week. And we were told to conduct a 3-year TDAM study investigating the policies, processes, and technical coordination mechanisms that enable TDAM science, and recommend 1 or more potential implementations for enabling TDAM science support. So really the thinking behind this was to say, we have all these missions, how do we make them TDAM better, right? So what came out of this is ACROSS, which is the Astrophysics Cross Observatory Science Support Pilot Project, which is an outcome of this TDAM study. And the idea is that we're going to put together, like a lot of people here today, software and data analysis systems to enable TDAM science workflows. And we're going to put together like a help desk for people who want to facilitate coordination with NASA missions and beyond. And we're going to have a TDAM community grant program, which I will skip over today because most people here are not funded by, not have the ability to be funded by NASA, but we'll be supporting both TDAM software projects and also observations in the future. So to give you some idea as to where we think ACROSS fits into the ecosystem, certainly at NASA, is traditionally we have these sort of data archives on the bottom, and there's alert brokers. So we're not replacing that infrastructure. The observers are the guys on the left, and the NASA missions are on the right, and we're sitting in the middle. And traditionally, we have like archives are kind of dealing with things that happened like a week to 10 days ago. And the interesting information when you're doing TDAM science is what's everyone doing right now, and what's the plan. And traditionally, you'd have to, if you wanted to know what every NASA mission is doing, you'd have to go to every single website of every single NASA mission and look, and sometimes they'd have the information on an API if you're really lucky, but most of the time it's like a CSV file or a text file or some like awkward HTML interface. So we want to kind of take all that information and homogenize it and provide it to the community in a unified interface that has both an API and also a web interface. And so I'll talk about this a little bit more. So yeah, so the idea is to have a sort of a live feed of observatory status parameters with API access. And the idea is to provide kind of planning and observation tools that enable both the missions to be able to plan the observations and also observers to get together and kind of facilitate cross coordination. We're going to build a TDAM toolkit. So this is a collection of open source software products to try to standardize TDAM workflows. An example of this might be to provide, not everybody has an API in NASA, and many missions can't afford to do it. But we're going to produce like standardized APIs for like producing, for example, TOO pages, and provide those to the mission so that they can easily implement it either on our platform, or because our software is open source, they can do it themselves. So we expect the things that we build to be deployed either by the observers themselves or on our system. And as I said, we have a grant program and web services through our portal. Essentially, you'll be able to see like feeds of what missions are doing, what the current objects of interest are, what the sort of, you'll be able to do like visibility calculations, feasibility calculations. All of this will also be available via a REST API. We support natively VO standards, so that's baked in from the start. And so follow-up hub for TOOs kind of talked about that, and decision to support and recommendations. So what we've done so far Well, we started community outreach by setting up a Slack channel, which is a simple thing, but trying to get the team, the sort of observatories that are interested in TLAM follow-up together for '04. But unfortunately, the most exciting thing we were hoping to come out of '04 has not come out yet, as we all know. So there's not been a huge amount of activity there. But in terms of talking to missions, we've been working closely with NuStar to as an experiment to ingest their plans. So that was working. And the main thing that we did earlier this year was to develop a product for BurstCube, which is a GRB detecting CubeSat, essentially to provide target of opportunity support for them. Now, target of opportunity for BurstCube does not mean repointing and looking at something. It's actually more of a download of opportunity. So the system that we designed was inspired by the Guano system on Swift, which Jimmy talked about yesterday, where essentially you have an ingester which registers all of the GRBs that are being detected by the various missions around the world and assesses their feasibility for being seen by BurstCube, and then records that in a website. And I'll, sorry, I didn't realize this slide was going to pop open like that because it didn't do that last night when I looked at it. Sorry. Anyway, so what you can see on the right here in the bottom right is kind of the output of this. Every time a trigger occurs, it's ingested into our BurstCube system. There's a web page that lists the triggers. And you can see that on the right, we've got the probability. Essentially, what we do is we take the HillPix map from LIGO or like the Fermi error region, and we calculate the probability enclosed by both that error region and the BurstCube field of view. Now, BurstCube is all sky. So the BurstCube field of view is essentially defined by all of the sky minus what's occulted by the Earth. But yeah, we do that calculation for them, and then the BurstCube team can take this and say, okay, these are the ones we should prioritize because, you know, the one on the bottom there, for example, has a 92.4% probability of being inside the field of view. And then they can download their data, because the reason why they need to do this is because they create so much data, they can't download all of it. So they can only sort of cut out sections and say, okay, there's a GRB at this time, we'll download this sort of, you know, from this time to this time, and then we can analyze it on the ground to see if we detected it. So this was done as a kind of example of how we can create this infrastructure. And this is all, for the technical side of this is all running on AWS. And it's actually been quite successful. We used it, BurstCube detected a GRB, and they've been using this system. Unfortunately, last time I checked, BurstCube was only 200 kilometers above the atmosphere, which means it's probably going to burn up quite soon. It launched in March. But they started off pretty low, and the solar cycle was pretty bad right now. Okay, so what's the next step? So we want a complete open source software release authorization. That means that all the software that we produce will become public on GitHub. We're going to acquire a permanent domain name. That's I can't tell you what it is yet, but it'll be something easy to remember, and it's not going to have a cross in it, just to let you know. Yeah, the whole idea is all these tools that we write, they'll all be public on GitHub, and it'll be a nice front end web page. We're currently working on incorporating data streams into the missions, including NuStar, Swift, NICER, XP, and TESS. And there's the same VO protocols are automatically included. And of course, we're going to continue working on the work we're doing. The idea is that this will become public sometime, I think, in about a year's time. So this is still like very much work in progress. So we're in year 2 of this study now. And we're sort of looking at now integrating ground-based observatories into our system. First part of that is visibility, which is a relatively simple thing, but getting information from ground-based observatories is quite tricky. So we will leverage as much of the existing infrastructure as there is. So if people like Aon, for example, we're talking, I've been talking to Rachel Street about how we can work together. So this is very much supposed to be complementary rather than something which is like taking precedence over other things. And, that's so we definitely want to be a good team member and not something which is, which is sort of like, you know, we're NASA and we're here to kind of like take over. And yeah, we're having a TDAM meeting next week, which is bad timing for me because it means I have to go to two conferences in a row. And we've been, as I said, we're meeting with lots of other people about this. So in summary, the across just finished the first year of the TDAM study, and the objective is to partner with science teams to provide services and infrastructure that enable the potential of TDAM science. We're continuing to do this study, and we're developing TDAM toolkits and APIs, web portal. There will be an AO for those who can apply for that, initially targeted for 2026. And community support help desk, documentation, tutorials, and workshops are being worked on right now. Thank you.